So, hello, good day. Thanks for coming to HashiTalks Deploy and listening to a little bit about this talk that covers Lambda functions and deploying them. So, let's move right along here. My name is Martin Smith. I'm a staff site reliability engineer at HashiCorp. My pronouns are he, him. My Twitter is there, and I work on the HCP platform, the HashiCorp Cloud platform. And today I want to talk to you about something I see posts about all the time, which is deploying Lambda functions and people building solutions and make files and bash scripts and PowerShell things and using frameworks. And we're just going to explore this a little bit and look at some of the sort of traps I've fallen into, as well as maybe make a couple of recommendations. I actually worked with somebody once who asked me. They said they find the deployment of Lambda to be so painful. They said it must not be very mature. And I think that's actually the farthest thing from the truth. I think what we're really seeing is that people deploy Lambda in all kinds of ways, and some of them are inefficient, or they take a while to re-upload a file when they don't have to, or they don't upload when they should redeploy, right? That's a case of the reverse, where you're maybe in an incident and you need something to deploy and the Lambda won't. And people say, well, why is it so hard? So to do that, though, first, there are bound to be some folks in the audience who haven't heard of Lambda at this point. So I just want to talk about what it is. It is a function as a service tool. So you've probably seen other of these as well. I've got some in the next slide, but it essentially lets you focus on the code that you're writing that's relevant to the problem you're trying to solve, instead of spending a lot of time, I hope, worried about patching servers, setting things up, downloading dependencies, making sure something's running, managing the runtime environment for code, right? Lambda takes your code and it runs it in its own special kind of VM type thing, uses some really nice technology to do this. Check it out if you're interested. But essentially, it's like a sandbox, and AWS Lambda takes your code and runs it and does something with the results. So let's look at some details about Lambda. It's started first release in 2014. That's really surprising to me. It feels like it's made a lot of improvements, but it doesn't feel like it should be quite that old. I've listed some of the ways you can write code in particular languages. They have multiple runtimes. For a long time, you could sort of use one of those to bootstrap your own language, but now they support custom ones directly. So there's some competitors there of other folks building similar runtime models. What else? It's event driven, so that's kind of interesting. You can listen to things that are happening maybe in other parts of your infrastructure or your application and run a Lambda in response to them. It can run inside your VPC, but it can also run not in your VPC. That was the inside the VPC thing was a feature that was added more relatively more recently. It has multiple architectures, so you can actually run x86 and ARM Lambdas. It also supports quite a bit of code. So in theory, you can upload 75, I think in 250 meg layers, you can upload gigabytes of code, 75 gigabytes. It also has a free tier, which is first million requests are free, plus the amount of compute time. It's in gigabyte seconds for the free tier limit. Another interesting thing is you can purchase savings plans for these, so you can actually save money if you run a lot of them. So they're a really viable option for certain types of applications or solving certain types of problems. One limitation of them I could mention is that the memory and CPU is tied together. You don't necessarily pick them separately. You pick your memory and then you get a corresponding amount of CPU. There actually are other disadvantages to Lambda, but I'm not really trying to sell you on Lambda per se. So check it out. It may work for your use case. And yeah, let's take a look at a particular use case. So this is a way to make sure that S3 buckets have logs on them, right? And they go to a log bucket of access to the S3 bucket. So what you're seeing here is Terraform or from GitHub with AWS CLI, you might deploy this enable bucket logging.py Lambda function. It sits in an S3 bucket itself. And on an interval, it says cron job here. We're talking about, I believe, CloudWatch events. It's going to run and it's going to look at all the current and new buckets and make sure that they're configured by just enforcing the settings on every bucket. And so there's also a use case for log shipping, which you see at the end here, which is you can actually configure a Lambda to run every time a file is put in an S3 bucket. And if you do that, you'll get that Lambda running and you can decide to ship that log somewhere else. Maybe you use Datadog or something that's not CloudWatch logs. Other examples, you can directly invoke a Lambda from the command line or actually from Terraform, I learned recently. You can have it being put on the internet and invoked by an HTTP request, either directly through Lambda function URLs, or you can put it behind an API gateway. That API gateway option has been around a little longer than directly addressing Lambda functions by URL. You can also have an SQS queue, and you can have that SQS queue every time there's something in it, you can run the Lambda. Some of the use cases for this, you could build a whole website around this. You could build some of that file processing type logic I talked about before. You can implement backups on a schedule where maybe some AWS product doesn't support backups or one of your products doesn't support automatic backups. You can actually just do that Lambda on a schedule to perform the backup, or maybe invoke the manual backup or snapshot option in some project. You can use it for stress testing. It has some concurrency limits by default, but it can go quite wide. You can also use it for, I really like this solution, CloudFront Edge processing of requests coming into CloudFront edges. So you could actually look at a header when a request comes into a CloudFront edge and decide to perform a redirect or set another header or do something with a request, and that's running on the edge near the user. So that's really cool that you can use Lambda to do that. You can also do custom CloudFormation resources with Lambda. So you could say, make up your own resource in CloudFormation and just back it with a Lambda. And again, there's a lot in there that I just mentioned, but some of them are maybe not great ideas too, depending on the architecture. There are downsides to Lambdas, like its 15-minute runtime limit. So I'm not trying to say that it's all perfect or that give you a big comparison here, but I just want you to understand maybe why folks are deploying Lambdas. So let's get into some of the simplest use cases for doing so. And so I want to just talk to you about how folks might deploy Lambdas. I'm going to show you some examples, but just a disclaimer. I ran all of these examples, but I'm not running the demos live here. We only have 25, 30 minutes. So verify this. You don't want to find out that I've edited something in a terminal. It doesn't work the way it should. So please go play with this, try it. I might eventually upload some of these files into a public GitHub repo. But again, no live demos here, trying to keep the time down and avoid the live demo gremlins. So here's what I want to show you first, which is just deploying a Lambda function from the console. You actually do a lot from the console, and the Lambda console text editor is a lot better than it used to be. It even has tabs now, if you see that in the screenshot. It wasn't always that amazing. You could do a lot in the console, though. You can configure it, you can monitor it, you can look at metrics from it. But one limitation is that the console's not going to load your Lambda if it's more than 3 megs. And as soon as you include some dependency for Node.js, for example, you're going to hit that 3 meg mark. Here's also an example. It's the first time I'm showing you what a Lambda function actually looks like. And so you can see here, there's some event data, and then there's context, which is about, which contains information about how the Lambda was run, maybe when it was started, so that you can check and see that it's not running too long. Maybe I forget all the things that are in there, but there's a whole bunch of stuff about where it's running, maybe the region, stuff like that. And then you can see that all this one is doing is returning some arbitrary data as JSON, and that's it. And as long as it doesn't throw an error, it can print things to standard out. It can do all kinds of stuff as long as it doesn't throw that error. And you'll get this back. And I'll show you how could we upload this if we didn't want to use the console. Say we do have the 3 meg limit in play for us. Here's another example of a Lambda function that's actually looking for something in an event. Even when you invoke a Lambda function synchronously, you can provide that event. But again, the event data there is user input, and the context data is typically all AWS provided information. This one just does some message formatting and returns a string, and it does spit the user input back out if you provide that certain value of first name. So here's the directory we put it in. I put it in a file called lambda1.py. I put it in a Python directory. There's some requirements in case I want to do additional dependencies. And here's me just zipping it up, calling it lambda.zip. You can see it compressed really well. It's not a particularly interesting file. And then what about if we were to update or create that function? Here's an example of that. I'm not showing you the create, but it's really similar. It has a few more arguments you need, but as you can see, really the update is very simple. You just supply a function name and where the zip file is, and that just kind of works. Let's see here. What do I want to show you next? Invoking the function is what I think is an interesting example. So you get this status code out of it. You can see the output of that one had my message in it. So you get like all kinds of information about whether it succeeded, whether it had a stack trace, when an error, all kinds of stuff. But you can invoke it by name. Lambda functions also have versions, which I'll talk about later, but it's more of an advanced feature of it. So you can actually even specify the version of the function you want to invoke. It's nice for rolling back. But command line things are great, but we want to do something with Terraform because we like infrastructure as code. We like to do code review, pull requests, big fan of consistency. If you have a lot of Lambda functions, I'm not wanting to type all that out manually. It's much faster to do that through automation. And it scales better to lots of functions, right? So I just want to kind of show you the resource here. There's an IAM resource I'm not showing you, which is needed for the Lambda function to run as like an IAM role. I'm not showing you that, but it is there, and I have it in my code when I'm running this. I just want to walk through the actual Lambda function resource itself a little bit. So it takes a file name. It has a function name, which is mostly used to display in the UI. It has this IAM role I mentioned. It has a handler. You can see Lambda1 was the name of my Python file, and then Lambda handler was the name of my function in that Python file. You can see I chose a particular Python version too. Lambda has a bunch of ones built in. That's that resource. What does it look like when you run this with Terraform? It looks like this. It says it has 2 resources to add. You can see my IAM role there. You can see the function after 6 seconds. Boom. Here it is. That was pretty easy. So I think this is the first time people start to get confused about Lambda or run into little pitfalls, right? So I want to show you updating your Lambda, which is just a Terraform apply auto approve. It says no changes. Your infrastructure matches the configuration. That's great. I hadn't updated the Lambda yet, so that's fine. That's what an update would look like, and there's no change. So I'm gonna modify the Lambda. And again, this is where I think folks start to run into trouble, is very simple modification here. I'm gonna do that same step I mentioned before where I zip up my Lambda into this lambda.zip from that lambda1.py. And I'm gonna run Terraform again, right? Just a slight modification. And it says no changes. And so I think maybe it's partly the AWS provider, but it's confusing that this says no changes. I literally just updated that file, and then I zipped it back up into that deployment object, the lambda.zip, and it should be there. So, I think the first time I saw this, I thought, well, maybe what if I just delete it? What if I just delete it entirely? Surely that's going to break something, right? Surely that will. So we're going to run our Terraform apply again. No change. So, um, darn that. What's going on here? This file doesn't even exist in Terraform. It says you're up to date. Everything's good. That's pretty confusing. So I want to kind of dive into the Terraform provider for AWS and see how does it decide that something has changed? And I found this one function. I think I've trimmed this one a little bit, but I kept the important bits. Um, and you can see here that these are the things that detects if the Lambda function needs the code package shipped back up to it. If the file name is changed that I'm shipping, so I didn't change that. Mine was lambda.zip. Has the source code hash changed? Turns out that's not something computed automatically. You just have to supply that if you want that one to be set on the function. So I didn't supply it, and it doesn't seem to be calculated, so it's probably not changed. I'm not using S3 to deploy my Lambda. If I was, these changes would matter. So kind of nice if the S3 object version changed. So if you had versioning on your bucket and you uploaded something, if S3 detected it had changed, you'd get a change. And then some other ones here, also ones that you would expect to cause a change depending on your Lambda deployment model and so forth. Let's use source code hash. It seems like the most viable one. I don't really want in my system that I'm building here to change the file name to have like the timestamp in it every time or something, because I actually do want it to be the same when there's no changes. So let's do the source code hash. And here's me adding it, right? Pretty simple. Now, when I modify the file, I can see that I definitely got a new apply. And I don't show you that here, but I'll show you that in a slide or two. Here's one thing I did just because I was curious. I used this base64 version of the SHA-256 hash of the file, but I wanted to kind of check it, right? This is relatively new in Terraform. I think it was added in like .11 or .12. So I wanted to see is it me? Is it, am I the problem? Is it the zip file? So I just wanted to kind of zip the file back up, and see is it reproducibly the same SHA-SUM. So turns out if you don't modify the file, yep, exactly the same SHA-SUM. You can see it here. It starts with 6226. And so I went ahead and I did that apply here, and with the checksum that I put in place and that I showed you 2 slides ago, this file base 64 SHA-256, I don't get changes when I don't make changes. That's what I wanted. But I did want to see, well, what happens if I do make changes with this new checksumming? And so I just touched the source file. I thought, well, maybe that'll make a change. And it did. You could see the SHA-256 sum here changed. If we touch the file, if we update so much as a timestamp, we're gonna end up seeing a deployment every time because the SHA has changed. And I just want to, as an aside, remind you that it's a fact of life in CI/CD systems that sometimes timestamps on files change even when the contents haven't. If not that, sometimes even just you're cloning a repo and you might even see that. So what happens when there is a change? You can see here that it shows the source code hash as a base 64 value, and it shows that it's going to change. I touched the zip file, or excuse me, I touched the Python file and zipped it back up. And that made the zip file checksum different. So cool. I don't want just a touch to update it. So what can I do instead? And I'm going to use another Terraform provider here that you might want to consider using if you're building your zip file yourself right now. And that's archive file is the name of the resource. And I'm going to just say, please zip up into this lambda_function.zip file, which is a slightly different name. I'm going to switch from lambda.zip to lambda_function.zip. And here's my directory with that source code in it. So I'm going to implement that. And I'm going to do it also. I'm going to make some modifications. Before I just had a file name here. Now I'm actually using the archive files output for that file name. And it also is going to give me the sum of the base64 SHA-256 checksum of the file it's created. So that's great. That's actually what I was looking at before with that inline function. So perfect. Does that work any better for, say, deleting a file and then having Terraform tell me nothing has changed? And in fact, it does. I can actually touch this file over and over, and I can do the apply, and each time it says there's no change, which is interesting because before I touched it, I touched the Python file, but I could even touch the zip file, and because it's SHA-SUM hasn't changed, nothing has changed. Now, what in an archive file is making these zip files suddenly be reproducible or idempotent, right? That's in the title of my talk. What's making it consistently do the same thing? And if you dig into the archive file provider's source code, you actually find this line, set mod time to this empty value. So that's really interesting. So somewhere at some point, somebody decided that's maintaining this provider that we're actually going to always make more reproducible zip files. So hope you're not using this provider for some place where you actually need a modified timestamp of your files inside the zip file. But in Terraform, archive file just does that. I don't even know that it's that well documented, but that goes a long way if you're going to use this to build deployment artifacts for Lambda. This goes a long way to making them more reproducible, which is great. This also has the effect of if you delete the file, it notices. That's great. We wanted that. And also, if you haven't made any change to the Python file, as we hoped, the zip file has the same checksum, and so we're good. But I wanted to kind of dig into like the history of this. I was really curious, given that I've seen for years people stumble on how they deploy Lambda functions. So I went and did the sort of get praise, get blame version on GitHub. They've got their little button for that. And I went and found the issue. And here's the issue, the bug report filed, where check out this quote on it. But somebody reported this and noticed, hey, it was saying that a zip file was like changing and re-uploading before this with the archive provider. And this quote says, I wouldn't recommend using Terraform as a build tool, whether you're making a binary or a VM image or a Docker container. It's just not designed for that. There's better tools. So it's so interesting that, I see this a lot in the Terraform community is that someone says, oh, you should do that with Terraform. You shouldn't do that with Terraform. You shouldn't use it as your Kubernetes deployment. You should use Argo. You should use it to template all of your Helm files or what have you, right? So there's really different opinions about it. And I'm going to share mine in a minute, but I do think that there's a time and a place for using Terraform to do your deployments, especially when you're deploying software that's connected to the infrastructure in some way. So if it's actually part of the infra, great, deploy it that way. If you're deploying an application and has nothing to do with the infra and you don't want to have your app changing or your infra changing when you're modifying the other, deploy it a different way. All great. I think what works for you is best here. But I wanted to tell you about some of the other things that I've seen here, like other tools that are not just Terraform and how they handle some of these situations like we just looked at. So I don't think I've mentioned this yet, but AWS has a serverless application model, CLI. It's built on CloudFormation, and so it actually uses CloudFormation change sets to detect that some things are changed. And it also does this thing where it says, I guess it used to use checksums of zip files like we just showed you, but now it does directory checksums, which makes sure it even has semantics for like whether a symlink means a directory is changed, but it does look at the file names and their contents as well. Another tool, Serverless Framework, actually does this thing that I've written here, which is it takes all of the hashes of all files in the deployment. So it's actually building the zip file, if you will, or whatever kind of deployment you're making. And it's checking the hash of each individual file, and it just halts. But they do need to provide a way to do this. So they have force. And then serverless is also based on CloudFormation. And so they also have a way to say, hey, just update the function, don't update the CloudFormation. So there's another layer of like change tracking and change control. And so one of the reasons I wanted to give this talk is that I keep seeing this pattern come up again and again of the idempotency of zip files or of various kinds of build artifacts, right? Um, and I mentioned a few here on this slide, which some of them really crack me up. Some of them go way back to when Perl was the dominant language. Even some of them are more than 20 years old. We got Python versions of it. We got ones as utilities in Debian. We have Golang implementations. There's also all of these like uploader CLI tools. I mentioned one there, the Lambda uploader, which I actually worked on in 2012 or 2013, something like that. And then I mentioned these two I just talked about a second ago as well, the serverless framework and the AWS SAM CLI. But I can't tell you how many times I see, whether it's a subreddit or somebody in a forum asking for help, or in Slack, on a community Slack, or somebody saying, Lambda's not deploying the way I want. And so I think a lot of it goes back to this like idempotency of build artifacts problem, which I find super interesting. There's also the AWS SAM CLI that I just wanted to show you an example for, where you could actually do multiple Lambda functions. And I'm going to mention that again. It can deploy tons of functions. It's based on CloudFormation. This is an example. And it can even pull lists of functions from other files. So like really geared on having a nice deployment instead of maybe Terraform, which is geared on reproducibility of environments, right? And that's a simplification, of course. Here's using GitHub Actions with it, and they actually supply some nice GitHub Actions too, and you eventually run a build and a deploy. These are vastly simplified because these YAML files were way too big. But you can see how this starts to turn from Terraform resources for Lambda functions, which are like first-class objects, to simply data. And so I like the idea of if you're building a lot of Lambda functions, you really want to represent them as data, not as behavior or code, right? So here's another example of the serverless framework, and it's YAML very similar looking. I've again removed some stuff here too. The GitHub action is almost identical for the serverless framework example. They provide very similar ones. So we're kind of coming up on time. I want to just take a moment to zoom out and make some observations about if you are thinking of using one of these tools, and if maybe you will run into one of those problems like the build idempotency. I think there are probably a lot of other interesting ones I could propose another HashiTalks deploy on. But I just wanted to sort of put some tiers or categorizations here. So a lot of folks are just deploying a handful of functions. They don't change often. They're often about the infrastructure. They're doing basic monitoring. They're looking at things like, does the Lambda invoke successfully? How long does it run? And what's the error count in the metric on CloudWatch? And for that, I really think that doing the archive file zip up and deploy with Terraform makes a lot of sense. I think this is not something you're going to want to do a bunch of scaffolding for if these are your only Lambda functions, and you're not going to have, but maybe, I don't know, maybe you ship a change once a month, right? Like you don't need Lambda function versioning. You may not actually need some of these more advanced deployment methods at all. This will probably solve your problem. A lot of infrastructure I see is deployed that way, that has a Lambda function to do one thing. Then there's sort of like a middle tier where I would say like maybe you're using it to actually do application logic functionality. I think it's fine for it to live like along an application, maybe in a GitHub repo, or a separate repo for Lambdas that is just all your Lambdas that you're versioning and releasing together. You might be doing more like things like test coverage. This is where CI/CD starts to come in. Maybe you're thinking about using the like Docker layer functionality instead of the zip files. But it's not infrastructure, or it's not as much infrastructure. And also I mentioned here, there's actually a really nice Lambda community module for Terraform that deploys Lambda. Shout out to the folks that maintain that. I know some of them, they're awesome. And that might be all you need. It has some more advanced features, but you don't necessarily still need a bespoke build tool just for this. This is where you might start doing things like monitoring whether your function is throttled or have concurrency limits that it's hitting because you're getting too many requests. This might be where your Lambda, as I mentioned at the beginning, is reading off of an SQS queue. Yeah, so check out the community modules in the Terraform registry. It's registry.terraform.io, but there's some really good work there. And that might be enough for you if you're kind of in this situation. Now, if you're building entire serverless applications with many Lambdas, you might be building it to actually, we talked about that example of putting a URL in front of a Lambda. You might actually be using it for customer-facing work. This is where I would recommend you start thinking about tools like the AWS SAM CLI or the serverless framework. This is where you probably don't want to be using Terraform or CloudFormation. You want to be doing more CI/CD tooling to call those CLIs. Normal SDLC applies here. You're going to be just doing regular code review and deploy like you would for any other application. It should have a GitHub repo like any other application. This is where you might also start considering things like monitoring. There's a metric for Lambda to fail to write to a destination or has a DLQ from SQS. This is where you might want tracing. This is where you might want to have your own metrics you emit from your Lambda. So again, you might also want to do more advanced deployment like blue-green or version pinning in the Lambda API. Those are both really advanced things that you might need if you're at this stage. So I'm going to stop there. I've talked a lot. I really appreciate you watching this talk and learning a little bit about how to deploy Lambdas with me and maybe take away some tool recommendations, or at least I've stopped you from stepping in a potential pitfall. So yeah, thanks again, and good luck to all the other HashiTalks presenters and the MCs. Thanks so much.